did. Wow.
That's all right. Okay, so let's take a look at my hand again. So I have 1, 2, 3, 1, 2, 3, 1, 2, 3. So the way I used to count is like this: 1, 2, 3, 4. Then they count this one: 5, 6, 7, 8. Then they go down: 9, 10, 11, 12. Aha! So with your thumb, they used to count, right? And that's where the 12 comes from. Now you got 2 fingers here, so we got, we got a whole bunch of fingers to count with. So that's why, we have 360 degrees in a circle. We have 12 months in a year. We have 30 days in a month and all that. So we can count easier with our fingers, right? So let's take a look at this angles in a circle really fast. And I'm going to share this with you. Actually, I don't need to share. I'm just going to change cameras. Let me change cameras real quick. All right, nice. So let's see. So we say there's 360 degrees in a circle. Right? Where did that come from? That came from the Babylonians, supposedly, but I'm pretty sure it came from Sumerians. Sumerians lived where Babylonians lived maybe 8,000 years ago. The Sumerians came around. We don't know who the heck they are, really. We don't know where they came from. We don't know where they went to. They're called Sumerians. So if you text me right now, I won't be able to see it because it's so tiny. It's like way away from my computer. Right? I'm about 10 feet away. So please don't text me, say something, but you can interrupt me anytime you like, please. All right, so now we say there's 360 degrees in a circle, right? So 360 degrees in a circle. And about how much is 1 degree? I think people's fingers are getting bigger and bigger because it used to be in astronomy books, your index finger at the arm's length. So if you hold your finger at the arm's length, this is an index finger at the arm's length, that used to be about a degree of the sky. So if you point it at the sky, you go, that's 1 degree. You can also check people's heads. You can go, that guy's head is 1 degree. That guy's head is 2 degrees, kind of like that. Nowadays, your book says your pinky. If you point your pinky at the sky, that's 1 degree of the sky. Now, the moon is a half a degree. The sun is a half a degree. So you should easily be able to cover the sun and the moon with your pinky. But you have to close one eye. You can't have both eyes open because you'll see the finger at 2 different positions. So that's what 1 degree is like. Now, this is called a right angle. This is a 90-degree angle. We call it the right angle. I'm not even sure if it's spelled W-R-I-T-H or R-I-T, but it's a right angle. So it's 90 degrees. So in a circle, no worries. In a circle, we have 4 of those, 4 90 degrees. So 4 times 90 degrees makes 360 degrees. So we have a 90 degrees here, we have a 90 degrees here, we have 90 degrees here, we have 90 degrees here, and so on, right? Like that. Now, if I go from the horizon, all the way to the zenith, right? How many degrees is that? 90 degrees, right? What if I go from the horizon to the other horizon? How many degrees is this? Well, that'll be 90.
180.
That's right. It would be 180, right? Like that. So this would be 180. 180 degrees. So when I say 180 degrees, that's what we're talking about. This is 180 degrees. And 90 degrees plus another 90 degrees, that's 180 degrees. All right? Okay, so what would this angle here be? Let's say this angle here, which is a half of 90. This would be 45 degrees, right? Like that. All right? So that's how we're going to count the angles in the class. Now, let's talk about horizon. We said horizon is where the sky ends and the earth begins. And you can see about 3 miles away. So you see the horizon about 3 miles away. Now, he said everybody on earth has a different horizon. So let me find the North Pole. Here's the earth. North Pole is up here. South Pole is down here. Let me grab a pencil. We said the Earth has an axis of rotation. So the Earth is rotating around this pencil here. This is the north axis of the Earth. 90 degrees from that, we have the equator. So this is the equator. This is the North Pole. This is the South Pole. Right? There's the South Pole. All right. Now, when we look at the celestial sphere, everybody sees it a little differently. So the celestial sphere is like this other sphere. This is actually a celestial sphere. Kind of like, you have the globe of the Earth. You have the globe of the sky, which is kind of useless. Why is it useless? Well, for most people, it's useless. Because you're inside of here. You're in here. Kind of like a planetarium. You're inside of the celestial sphere. This is God's vantage point. If you're outside of the universe, looking in, this would be the universe, right? So the celestial sphere is really surrounding us. That means this Earth is surrounded by a much, much bigger sphere. It's endless. But we have to give it some size so we can draw it and use it because it's so useful for doing calculations, angular calculations, to figure out, like when is there going to be their lunar eclipse? When is the sun going to be at such and such an angle in the sky? Things like that. And you can do it as well as I can. Anybody can do it, basically, if you try. All right. So we said this is the North Pole. Right here is the North Pole. At the very top of the Earth is the North Pole. Now, this would be Santa's horizon. So when Santa looks around, this is his horizon. This is where he parks his sleigh. This is where all the, the reindeers are. Mrs. Santa is up here, she's having a good time. So everybody's up here, Santa's workshop. Now, if I go all the way to the equator, and we call this guy Jesus, who lives at the equator of the Earth, in Africa, let's say, then this is his horizon, looks something like this. Of course, it's not as big, but remember, this horizon goes all the way to the sky. I just don't have that big a circle that goes all the way to the sky. So this is an approximation of where you live, basically, if you live on the equator. So right now, I'm standing on a floor. If I take this floor and go all the way to the sky, then that'll be my horizon. But I also live on this floor here, right? There's a flat floor all the way to the horizon, an imaginary floor. All right, so this is that imaginary floor at the equator. This is an imaginary floor for Santa. This is an imaginary floor for somebody that lives at the South Pole of the Earth, Antarctica. And San Diego is right here on the Earth. Here's a map of the United States. San Diego is right here. So my horizon is San Diego. It's kind of like this. Okay. Now, if you go to the equator, your horizon is sliding down like this. If I go to the pole, it's be like this. So if I lived here at the pole, I'll be right at the stick. This is the North Pole of the Earth. So this axis of the Earth points to a point in the sky. There's a point in the sky called North Celestial Pole. So if you're Santa and you live up here, I don't know how many things I can handle in one hand, but let's say, I think I just broke the Earth, you guys. That's all right. We'll get ourselves another Earth. Just don't break the wheel first. Sorry.
You said you were going to give us some warning before we would die on the Earth earlier today.
Yeah, I will. No worries. I'll give you yeah. This is just a broken Earth. It's not that bad, but people are not broken. I don't know why this thing doesn't stick, but this is somebody who lives at the pole of the Earth. Now, he looks up at the sky. He's looking straight up. He'll see North Celestial Pole because that, by definition, this is North Celestial Pole here, right? North Celestial Pole is where this stick is pointing at, right? Like that. All right. So now let me change cameras again. Is there any questions? I see a whole bunch of stuff here. Remember, Monday there's no class because of the President's Day. We don't have a class, so no worries here. Steve says probably say, dude, is there anything important I should see here, you guys? Yeah.
Yeah, I was really complimenting your circles. They're amazing. You make it look effortless.
Well, if you draw circles for 40 years, you know, you'd be good at it too. So yeah, no worries. Everybody's good at it. You just have to practice. You have to have a whiteboard like this in your bedroom, and you practice. That's all you do.
I'm gonna get one.
Yeah, yeah, sure. My son has got one now. He's into it. All right, so let's take a look at this real quick. Now, here is me. Let's see. Can you guys see it? Thomas, give me a yay if you can see it.
You see it.
I can see it.
Yay. Okay, so this is San Diego. This is the way we see the horizon in San Diego. This is the constellations that we've used stick figures with. We draw lines between the stars and make the shape we call Ursa Minor, that little bear and all that. And so now I'm going to mark the celestial sphere here. I'm going to go to, we're going to say celestial poles. Here's a celestial pole. That's North Celestial Pole. Now, it's the same angle from the horizon, if you look at it in San Diego, as it is our latitude. Our latitude is also 32.5 degrees in San Diego, so this appears to be 32.5 degrees above our horizon. So if I asked you, if you live at 50 degrees north, what is the angle between the horizon and North Celestial Pole? And you would say 50 degrees. So this is 50 degrees. There you go. This is 50 degrees. So if you live in 50 degrees, North Celestial Pole is going to be farther up above your northern horizon like that. So this is it. 50 degrees. And I can count it if you don't trust me here. You should trust me, actually. I'm probably your best friend at Mesa College. All right, there you go. It's 50 degrees, right? Okay. So if I go to 0 degrees, then it'll be 0 degrees above my horizon. This is 0 degrees. So now North Celestial Pole is 0 degrees above my horizon. So this is a view of somebody that lives at the equator of the Earth. Is 0 degrees. It's right at the horizon for him. Okay? Now, when stars rise at the equator, they're kind of weird. This is east. Things rise in the east. Why do things rise in the east? Because the Earth rotates from the west towards the east. And that would be, if I look down on the Earth from the North Pole, like I'm Superman, looking down at the North Pole in Santa Claus's house, when I look down, I would see, you know, I would see Santa's house just directly below my feet, rotating for me counterclockwise, the opposite of clockwise. All right. So now let's take a look to see how stars rise here at the equator. Look at that. They go straight up like that. And the way they set is kind of funky too, because they set kind of like snowfall. Look at that. There's just snowfalls like that, all coming down. So the sun is going to go up and down perpendicular to the ground, which is pretty weird, right? All right, so now let's go to Santa's place, which is 90 degrees away from where I live. It's 90 degrees. Oh, where's North Celestial Pole now? It'll be on top of his head. It's in the top of the sky. This is the highest point in the sky. So at Santa's place, from North Celestial Pole, by the way, Polaris is right next to North Celestial Pole. From Polaris to the horizon is 90 degrees because he lives at 90 degrees north. Now, if you look in the east or the west, nothing is setting. If you look in the east, nothing is rising. Okay, geez. I'm waiting for the HR at Southwestern College to call me, and they still haven't called me. I don't know. I guess some people still work remotely, but they don't do any work. All right, so now nothing is setting here. I'm looking at the west, nothing is setting. I'm looking in the east, nothing is setting. So nothing rises, nothing sets, except for the moon, the sun, the planets, maybe, depending on where they are. There's a moon here. And maybe, you know, asteroids or things that are moving like satellites, things like that. Stars don't set here. If the sun is in the sky, it's going to be a while for it to set. So I'm going to put the sun in the sky. I'm going to make this August. There, now the sun is in the sky. The sun keeps going around. When the grass is green here, that means the sun is in the sky, and the sun doesn't go down. It's just always in the sky. This is called a 24-hour day, right? It's continuously sunny. Except one rotation of the Earth is not exactly 24 hours. It's 23 hours and 56 minutes. Next week, I'll explain why this 4-minute difference between our 24-hour day, and that's called a solar day, and also something called sidereal day, which is the 23 hours and 56 minutes that this Earth actually rotates, all right? Okay, so now what if you go to like 80 degrees north? So I go to 80 degrees north, and things do set, except just momentarily, right? Especially if I change the time here. So now the sun went down, it's coming back up. So you're gonna have a night that is very, very short. The sun is in the sky, the sun is not in the sky. Darkness, 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 darkness. Sun is rising, and sun is setting. So they have a little bit of daytime, maybe 3-4 hours of daytime. Now, let's go back to San Diego. Let's go home to San Diego. So I'm going to say 32 degrees again. This is San Diego. And I want to look at the south now. I want to see what's in the southern part of the sky. So here's the southern part of the sky. And I'm going to put in the celestial equator here. So the celestial equator is going to come in for you. This red line here represents the celestial equator. And this happens to be the very first day of fall, where the sun is exactly on the celestial equator. It's a special day, right? It's a very special day. There's another special day just like that. That's the beginning of springtime, right? A lot of people celebrate that day too. All right, now, what is the angle here? In other words, the question arises, if everything above the celestial equator is in the northern sky, so this is my northern sky in San Diego, everything below it is in the southern sky, I don't see much of the southern sky, but I see some parts of the southern sky. So the question is, how many degrees of southern sky do I see from San Diego? And how many degrees of southern sky do I see from North Pole? And how many degrees of southern sky do I see from, say, equator or someplace else on Earth? And I'm going to explain that to you guys by using that celestial sphere on the board. So let me just measure it so you guys can see how many degrees of southern sky is visible from San Diego. So I'm going to measure the angle from the equator of the sky to the all the way down to the horizon. It's about 58 degrees. 58 degrees. Let me see. Why 58 degrees? I can see 58 degrees of southern sky. Now, these things rise and set fairly quickly. Take a look. Actually, let me slow this down a little bit. So things rise here. Look, this guy here just rose and is setting already. It's only in the sky for just a couple of hours. So I don't see the stars in the south for a very long time. They rise and set very quickly. Whereas things here, they're in the sky for more than 8 hours, sometimes 12 hours, sometimes even longer than 12 hours, like 24 hours a day they could be in the sky. So what is the deal? The deal is the way our horizon works, what I just showed you at the beginning of the class. So the way my horizon works, this is what I see in San Diego. What if I went to, let's say, England, 50 degrees north? Can you guys guess how many degrees of southern sky I can see from here now? Take a guess. 40 degrees. I can see 40 degrees of the sky from 50 degrees north. Huh, like Spain. Why is that, I wonder? Now, what if I go to 70 degrees north? I see even less. Can you guys guess what this angle here is now?
20.
20. Now, who was that?
Omri Rodriguez.
Henri Rodriguez. Thank you. That's exactly right. So, how did you figure that out, Henri?
Well, I just did 70 or 90 minus 70 because it's 90 degrees total.
Very good. So you just subtracted the 70, which is my latitude, from 90, and you got 20 degrees. Is that right? He's going to say yes. Okay, thank you very much. So you got a point for that, Mr. Rodriguez. All right. So let's show you why this is so. And if you have any questions, please interrupt me. All right, so remember, angle from horizon to the other horizon is what now? 180 degrees, because it's 290 degrees, right? 190 degree, another 90 degree. That's 290, that's 180 degrees from horizon to the other horizon. Let me just kill this and make you a celestial sphere. I'll make it blue this time. Let's see, celestial sphere. Oh, okay, there's a celestial sphere for you. Yeah, it's not perfect, but it's, we'll live.
Pretty good.
Okay, thanks. Here is the celestial equator, right? Okay, so this is celestial equator, celestial equator. We call this whole thing the celestial sphere, right? So this is the celestial sphere. Celestial sphere. Yay. All right. Now, let me put the Earth in here. This time I'm going to make the Earth black. So the Earth is about here someplace. There's the Earth. Here's the equator of the Earth. Can you guys see the equator of the Earth? Is that visible from your camera, hopefully? Now I'm going to put in the axis of the Earth. So here's the axis of the Earth. Yay, the axis of the Earth. And the Earth is rotating this way. Okay, great. So this is the north pole of the Earth. This is the south pole of the Earth. I follow the south pole of the Earth until he hits the sky. It's never going to happen. We're just playing games here just to see how geometry works. That's all. Don't take this seriously. So this is south celestial pole. South celestial pole. This is the north celestial pole. North celestial pole. There's south celestial pole, north celestial pole, the celestial equator, which is the projection of the Earth's equator. Remember, I increased the size of the equator of the Earth until it hits the sky. It doesn't happen in our imagination, right? Okay, now I'm going to put in some horizons. So we said Santa's horizon looks kind of like this. Santa lives up here. And then if you live at the equator of the Earth, your horizon is perpendicular to Santa's like that. If you live at the South Pole, your horizon is here. And what about San Diego? Well, San Diego is here, so my horizon is kind of like this. And let me actually use my ruler here and draw a perfectly straight line. Here is San Diego. My horizon is going to end at this point here. All right, so that blue line represents the horizon in San Diego. So I see this much of the southern sky because all the stars here are in the southern sky. This is the southern sky. These stars here above the celestial equator towards the north, this is the northern sky. Northern sky. Northern sky, southern sky, right? So do I see all the stars in the northern sky? These are below my horizon. Do I see them all? Yes. Why do I see them all? Why see them all? Because my horizon is rotating with the Earth. Because the Earth rotates, my horizon rotates. So if this is my horizon in San Diego, as the Earth rotates, my horizon is rotating with the Earth. So then this horizon here will rotate, and I can see all the stars below my horizon in the northern hemisphere. And of course, some in the south. I'll draw that at the very end so you can see how much of the sky is visible. All right, so now, question. What is this angle from my horizon in San Diego to North Celestial Pole? What is that angle? I live at 32.5 degrees north latitude.
122.
No, we just saw it, right? I live at 32.5 degrees, so North Celestial Pole will appear how many degrees above my horizon?
32?
Not
32.5 degrees. It's the same as your latitude. If you haven't written this down, please write it down. You know for sure it's going to be on the exam. So if you live at 55 degrees north, England, how many degrees above your horizon will you find North Celestial Pole?
55.
55. If you live at 0 degrees north at the equator, how many degrees above your horizon is North Celestial Pole?
0.
0 degrees. Just like it's the same. So this is 32.5 degrees. 32.5 degrees from my horizon all the way there. Let me put something here so you guys can see that that's my horizon. So in my horizon, I have a bicycle. I actually do have a bicycle. Here's my bicycle.
You said you were going to bring it in today.
I will. I can bring it in. Not a big deal to bring a bicycle. Okay, so there's my bicycle. So this is my horizon, all right? What else do I have? I don't know. I have a dog. There's your head. Jesus, I have to draw a dog now. Here's his tail. This is front foot, back foot, ears. There's my dog in San Diego, all right? That's my dog and my bicycle. So that's 32.5 degrees. Now, how many degrees is it from North Celestial Pole to the equator of the celestial sphere? What is that angle? This angle here, from here to here. We said every circle has 4 90-degree angles. So this is just 90 degrees, very simple. From here to here, it is 90 degrees, right? Like that. Okay, so that's pretty simple. I hope everybody follows the fact that the circle has 90 degrees, 90 degrees, 90 degrees, 90 degrees, 360 degrees. So if you don't know that this is 90 degrees, talk to me after class. I can help you see that this is 90 degrees for sure. Now the question is, what is this angle here? This angle here is what we're looking for. How much of the southern sky, how many degrees above my horizon is the celestial equator? Which is the same question as, how many degrees of southern sky can I see from San Diego? So let's figure this out. What is
58 degrees.
Yeah, well, yeah. So yeah, thank you. So this, from this side of my horizon to the other side of my horizon, that side there, all the way to that side there. How many degrees is that?
180?
That's it. Thank you very much. 180 degrees. So if this whole thing is 180 degrees, this is 32.5, this is 90, then what is this? Ha! Okay, let's do it. So we go 32.5, add the 90 to it, and we get 122.5 degrees, right? That 122.5 degrees is from here to here, right? It's from here all the way to here. That's 122.5 degrees. All right. Now I'm going to subtract that from 180 to give me this. So this whole thing is, oh, sorry about that. I should have gone all the way down and nobody said anything. All the way to here is 180 degrees from one side of my horizon to the other side of my horizon. So to find this, I got to subtract 180 from 180, this 122 and a half. So I'll do that. I go 180 minus 122 and a half. And what do I get? 57.5 degrees. That's right. I got 57.5 degrees. All right. So now, is there an easier way of doing this? The answer is yes. The answer is all we really had to do it quickly is to do the following. All I have to do is to subtract my latitude from 90. That's all I have to do. And then I get the answer. So I go 90 minus, this is from San Diego. From San Diego, I get 90 minus 32.5, which is my latitude. And I get 57.5 degrees. So I can see 57.5 degrees of southern sky from San Diego. Or you can just say in general. So this is in general. In general, you take 90, subtract your latitude. And what you get is how many degrees of southern or northern sky is visible from any location on Earth. Like that. All right. So that's it. That's just that simple. So now let me see if you guys can give me some answers here. Let me see. So if I lived at 20 degrees north, how many degrees of southern sky can I see?
70.
70 degrees. That's right. That is exactly correct. Who was the first person that said 70 though?
Mackenzie.
Mackenzie said, okay. Mackenzie, what was your last name?
Simpson.
Okay. That's right, Mackenzie. Thank you. Now, I can't keep giving these points if I just keep asking questions, but I need to ask you guys again, just to make it more simple to follow. If I lived at 90 degrees north, how many degrees of southern sky can I see?
0.
0. So in Santa's place, then we see no stars below the celestial equator. We don't see any of the southern sky at all. And so how many degrees of southern sky can we see from the equator?
90.
90. That's all there is, 90. So we see all of the southern sky from Ecuador, let's say, from the equator. Do you also see all the stars in the northern sky?
Yes.
Yes. So who's the only person in the world that can see both all of the southern sky and all of the northern sky? And the answer is the guy
Jesus.
named Jesus. That's right. Very good. So now here is me. I'm Jesus now. I'm looking at the south. I see South Celestial Pole. And then I look in the north and I see North Celestial Pole. That's the only place in the world that I can see North and South Celestial Pole and the entirety of the entire sky. I can see all of the sky, northern sky, southern sky. That's the only guy who can do it. But even then you have to go on a higher, mountain or something. You have to get your altitude above the ground a little higher. Otherwise, North Celestial Pole is going to be right at your horizon. And it may be refracted. So, if you go up above, a hill, you'll be able to see it. Any questions?
We're saying that Jesus can see it from the celestial equator or the Earth equator? See both southern celestial.
Jesus cannot go to the Earth's, to the sky's equator. That's an impossibility. If Jesus can go to the sky's equator, he will be God.
Yeah.
Yeah. So he can't go.
So
He's
just
on the
here.
Earth. So from the Earth, we're talking, right?
Mm-hmm.
So from the Earth's equator, you can see all the stars in the sky, the entire celestial sphere. But you have to wait. You can see only half of it at a time, right? You have to wait for the Earth to rotate. So if this guy waits for the Earth to rotate, everything will rise. Everything in the northern hemisphere, everything in the southern hemisphere, everything will rise, sees the entirety of the sky like that. Everything. So here, celestial equator is 90 degrees from the southern horizon, 90 degrees from northern horizon. It's a very unique place. It's a very special place. Hot, hot, hot as well. Okay, if you guys followed all that, I finished everything we needed to do this week. We're kind of ahead. So if you guys have any questions, I'll be more than happy to answer those questions.
I have slightly an on-topic question, but it's a little bit not on topic.
Okay, please ask. If there's any questions, as long as it's not about Britney Spears, even though I really like Britney Spears.
No, so I know you stated that later on you're going to explain why there's a situation where there's a place that doesn't have it's 23 hours and 56 minutes. It just kind of made me think of leap years. Why is it that we have that extra day? Is it because every 4 years, even though we do a full rotation? Can you explain leap year?
Yeah, sure. So the Earth goes around the sun, we say 365 days, right? How long does it take the Earth to go around the sun? 365 days and a quarter day. So every time we go around the sun is 365 days and a quarter, not 365 days. So those quarter days, every 4 years, they add up to a whole day. So quarter day, quarter day, quarter day, quarter day, that's one whole day. So that's why we do it, because it takes 365 days and a quarter, not 365 days to go around the sun. But that's about the revolution of the Earth around the sun, not the rotation of the Earth that we're talking about right now, right?
Yes, sir. Yes, sir. That's why I was like, it's a little off topic because we are
No
focused
worries.
on the Earth, not
Sorry.
the rotation.
Those are wonderful questions. Thank you so much. What's your last name?
Peyton.
How do you spell it? Peyton. Okay, like Peyton Place?
Indeed.
Okay, very good. You got a point for that question. Very good. So that it's because of that revolution of the Earth that the days also get to be 4 minutes. That 4 minute that we're talking about, instead of 365 days, 24 hours, we only have 23 hours, sheesh, and 56-minute rotation of the Earth. So the 4 minutes that the Earth rotates, and the discrepancy between it and where the sun appears to be at 12 noon tomorrow is that 4 minutes. Does that answer? We'll talk about it more when we get to revolution. We're gonna get revolutionized next week, all right? So I'm gonna let you guys go early today. We're done, and I'll try to put some homework for you guys on the weekend, not to make you miserable, but it'd be easy homeworks. First week, I'm going to take it easy on you guys. All right, Darius, you take care of yourself, buddy.
Thank you.
All right, you guys, I like you just the way you are.
Thank you so much, Professor. You have a nice day, man.
Take care of yourselves,
Thank
buddy.
you so much.
Thank you.
We see
Thank
your
you.
dog.
Thank you.